Hello everyone, this is Official Sando. Today we're going to talk about Leetcode 358, Rearrange string K distant part. If you like my videos, please click like and subscribe my channels as below, so that more audience can find my videos recommended by YouTube. You also can find the complete codes for this problem and the complete video list in the link description below. Let's look at the example first. So this problem is give a string and an integer. Then we need to rearrange the string. Basically just construct a new string such as the same character side this distant k. Let's look at examples to understand what's the requirement for these problems. We are given a string a, b, b, c, c, and k equal to 3, which means between three distance we cannot have a duplicate character. So we can rearrange this for ABC, which use all the characters in S, but we also make the distance policies satisfied. The second example, there's no way we can make three distant part because we have to, for the first game, we had to use ABC to make sure they are apart three distant way. However, we have used up the B and C, so the only character we can put is the rest of 2A here, which is against the distanced policy. So there's no possible to rearrange a string. We output the empty string. Then the third example, every same characters has two character distance apart. So we can rearrange this for AB, AC, AB, CD. I think these examples explain the problems pretty well. So please pause here and think about how you will solve this problem. My solution is to use a priority queue. So I will use this example to explain my solution. Given string AAA, DBBCC, and the same character has to be two distant apart. First, to construct a dictionary to count how many characters will appear in the string. Then we put a dictionary into the priority queue. So after we count, our priority queue data is as this. So 3A, 2B, 2C, 1D happens in S. Then priority queue ordered by the number of counts appear from the most frequent one to the least frequent one. Then what we do is for each scan, we take out the top k characters to order the new substring of the final output. So here we pop out the first two, since case 2, we pop out the top two pair. So here right now it's A and B, and we adding the A, B in the final output. Then since we use once for A and once for B, so our count A become 2 and B come to 1. After we have done this, we put this cache back into the priority queue. Then our new priority queue will like here. 2A is still in the top because A count of A is 2, and right now C up to 2, up to the second place. Then 1B and 1D. As previously, we use the top two here to generate a new substring of the final output. So we use AC. So now each count reduced by 1, so we got a 1A and a 1C in the cache. After we've done this, we put the 1A and 1C back to the priority queue. Now, for each characters, we end up all have only one count we can use. We still use the top two. Then our output is like A, B. So here, since A and B has only one count left, we want anything saving the cache. So in the priority queue for next iteration, we don't have A and B anymore. So we only have C and D. Then we take the top two, and the C and D count right now is 1, so we use them, and we finish the whole iteration to rearrange the new string, which is A, B, A, C, A, B, C, D. Right, let's take a look for the code. In the implementation, we create an onward map to count of each character. We also create a priority queue to store pair as int and character. Since we put the int first, the default order engine in the priority queue will pick these elements to sort the whole priority queue. Then we push all the pair in the dictionary into the priority queue. Then we start our iteration. We will continue to do our iteration until the priority queues go empty. During iteration, we'll create a cache, which will store the pair of the elements count greater or equal to 1. Then when we continue to take the top one from the priority queue. So here is the early return. If the top frequency greater than 1, but the size smaller than k, which means we cannot meet the k distant part, since we don't have more than k elements in the priority queue. So we'll return empty string. Then we have a for loop iterations from every sub iterations we're going to k time. If the priority queue is empty in these times, means we need to stop in the middle, and this is the last scan, which means then we take the top elements and pop them and append them into the result, and we reduce the frequency. If frequency greater than 0, we push into the cache. After we done this k for loop iteration, we push cache back into priority queue. Then we continue this while loop till the priority queue goes empty. At last, we will return the result. So next, let's analyze the computation and the space complexity analysis. For computation, if we assume we have a string length as n, so for each iteration, at most we will do the n-scan for loop iteration, which is mean the k is 26 basically. So we will do the log 26 for the sub iteration. Then for the bigger while loop, let's say we're going to do the n times, because we have n elements in the string, right? So the whole commutations can be n multiplied log 26 in most. So here actually is a constant. So based on the big of O analysis, actually big of n multiplied log 26 is a constant. Actually is big of n. In terms of the space complexity, we have a priority queue here, and we have a dictionary here. We have cache here as well. So actually, since the maximum character of map will be 26, right? So given we only have a small capital A to small capital C, so I think I make typo here. So actually this is big of of 26 at most. Then it's nothing of big of n eventually. So yeah, I think this is the final space complexity. All right, so hope you enjoy this video. Please drop your comment and the suggestion in the video below. See you next time.